This is a question on DC motor, and in the first part, you are to draw the direction of forces on A, B, and C, D. So if you trace the direction of current, notice that the current will enter via the left side from A to B, and from C to D, and going out of the circuit of the coil. So the direction of current is now indicated in the diagram, and these two red arrows are the direction of the force. This is the orientation of the left hand, and just verify that the magnetic field is from north to south, and your index finger is pointing towards the right. The direction of current for A to B on wire AB is from A to B, so the middle finger is pointing into the screen, and the thumb shows a downward force as what is shown in our answer over here. And over here, the current is going from C to D out towards us, and the middle finger is pointing out of the plane, and the thumb is going upwards, indicating that the force is upwards on wire CD. So with the force on CD being upwards and the force on AB being downwards, we will see an anti-clockwise rotation of this coil. Now, when the wire CD rotates to the north pole side of the motor, we notice that because there is no split rings, the direction of current in CD will never change. The direction of magnetic field lines will never change. So the direction of force on CD will always be pointing upwards. This therefore will result in this issue where the coil will first start rotating anti-clockwise, and once it goes past the vertical position, the force on CD remains upwards, no change to it, and the coil will then want to rotate clockwise past the vertical position, and then want to rotate anti-clockwise, and so on and so forth. So the coil will therefore be sort of vibrating about the vertical position, and ultimately coming to rest there. And therefore, this means that this kind of motor without a split ring, it cannot continue to turn in an anti-clockwise manner. So right now we have a proper DC motor with a commutator ring, and you are to determine the polarity of the side Q. So we notice that the coil is rotating in a clockwise manner, and using the info, we will notice that the blue arrow shows the direction of the force on the coil, and only with this direction of force then the coil can rotate in a clockwise manner. A second piece of info is given by the polarity of the battery, where current enters the loop from the left side, and the black arrows over here shows the direction of current in the loop. So with these two directions known, we can then use Fleming's left-hand rule to determine the direction of the magnetic field lines, and that's how we can get that the direction of magnetic field lines is from north to south, from Q to P, if you orientate your left hand properly. And therefore, the magnet Q carries a polarity of north. Now, over here, the coil is again rotating in a clockwise manner. You are to explain what causes the rotation. So we have to say that there are forces acting on the coil. So on the side near coil P, there's an upward force. On the side near coil Q, there's a downward force. And these two forces will result in a net clockwise moment that makes the coil rotate about this central axis. Now in part B, what happens to the coil when it reaches the vertical position? So this is where the carbon brushes will be exactly at the gap of the split rings. So when this happens, there is no current going into the coil, and therefore there's no force acting on the coil at all. But because the coil was already rotating prior to this, momentum will carry the coil past this dead zone, and once the split ring rotate a little bit more, the electrical contact will be made and current will flow in, and the coil will experience a force again, allowing it to rotate continuously.